Alright, so let's go back to our problem. We need a way to represent a point, something that exists in the real world, and represent it as data in our program so that we can manipulate it. Okay, so here's our first attempt at trying to represent our point as data. Why not? We take a point and then say that a point means two ints, maybe x1, y1. And because we're going to accept 2 points, maybe we'll have x1, y1, and x2, y2. All right, let's try that. So our signature then will become int, 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 int. And then, let's say the way we want to represent a slope is a float. So let's say float. Okay, let's keep going. Our stub will look something like this. Float, slope, given int x1, int y1, int x2, int y2. And since this is a stub, we'll just return a dummy value, 0f. Save that. All right, all well and good. So it seems reasonable to represent a point using 2 ints. But notice something. I think we talked about this in the previous class. It isn't very expressive for now. The signature, the header, is not really telling me anything about the relationship between x1 and y1. They both end with 1, so there's a clue there. But it doesn't really tell me that taken apart, these 2 ints don't mean anything. They only mean something, they only represent something in the real world, our point, if they're taken together, both x1 and y1. Further, it's not very concise. So we gave an example in a previous lecture about how the more and more points you have in your program, you're going to have more and more ints. We got to a point where, pun intended, that if we wanted to represent 2 rectangles, we needed 1, 2, 3, 4 points for each rectangle. And then because we had 2 rectangles, we needed 8 points in all, which means we needed 16 ints as our signature for that function. It's not very concise. Okay, so that's where structs comes in. Structs are a way to define your own types. It is when you notice that the thing that you want to represent in the world cannot be represented using a single atomic primitive. In other words, the primitives that we have are ints and chars and floats. And they're atomic because you can't break them up. So when we realize that the thing that we want to represent in the world can't be represented by a single atomic piece of data, then we should define our own type. A compound type may be a type composed of other primitives. That's where that's what structs are. Okay, so let's define a struct called point. When we do that, it will look like this. We're defining a new type, and then we're saying this struct type. This type is a struct, and then around curly braces, we'll say what composes this struct. What is this struct composed of? Let's say it's 2 ints, so int x and int y. And then let's name our type. Let's call it point. All right, no errors there. Now, we've just made a new type to represent a point. Something in the real world we're representing as data, but not as single atomic primitives, but as a struct compound form of data. Now, our code can be more concise. Instead of saying we'll accept 4 ints, we can just say we'll accept 2 points. Point A, maybe, and point B. We'll also change our signature to say we'll accept 2 points. Okay, so here are the advantages of that. Because we made point as a compound type, now our code is a lot more concise. It isn't as long. So if we had, for example, instead of having 16 ints in that previous example that we had, maybe we only have 8 points, right? And we can even go further if we want to compose another struct, let's say called a line, then we could compose it using the types that we define, like a point. We'll talk about that in a later video. But the point that I want to make here, structs are useful for us because they allow us to have code that's more concise and code that's more expressive. Previously, with the previous definition of our slope function, the relationship between x1 and y1 wasn't made very obvious. And if they were taken apart, they would not mean as much. But now, we're saying that x and y should always go together. A point cannot have just x or just y. It needs two values.